Correctness shouldn't depend on an engineer remembering to be careful. In this framework, we distinguish guidelines from axioms. An axiom is a property the system is built to make violations of structurally visible. Our pipeline is a pure function of its inputs, inspectable at every seam. It flows through 12 distinct phases, accreting state into a single serializable object. Axiom 1, the graph is the deliverable. All product logic lives exclusively in graph nodes. Orchestration scripts like orchestrate -py are merely the harness. We eliminate the side script decay path. Every artifact, from diagrams to the final DIKW dossier, is the return value of a node, never an out-of-band side effect. Axiom 2, everything accretes into one state object. We use a single type dict with 50 channels. This avoids the O(n)² wiring problem common in multi-phase pipelines. Because all state is one object, the entire history is available to any later phase for free. A phase 10 node can access phase 1 output without complex intermediate threading. Axiom 3, each phase is a compiled subgraph. This ensures independent testability. You can invoke any phase in isolation with a partial state for unit testing. Reducers are the law here. They govern exactly how concurrent writes merge. Pick the wrong reducer and the graph fails loudly with an invalid update error, which is exactly what we want. Axiom 4, visible structure over hidden logic. When a taxonomy, like the 15 COBIT information quality criteria, drives behavior, we reify it as sibling nodes. The graph becomes a legible specification of intent. You don't read code to see what data quality criteria we assess, you simply look at the studio canvas. The taxonomy is the wiring. Axiom 5, one GPU, one model at a time. The hardware constraint is real. A 24GB RTX 4090 cannot co-reside a VLM and a 30B coder. Orchestration manages the model lifecycle. The graph stays model agnostic, while the harness handles the stateful, timeout-laden choreography of swapping resident models between phases. Axiom 6, idempotent persistence. Every phase is followed by a persistence node keyed by stage name. Rerunning the graph is a safe, idempotent operation. We make persistence a node in the flow, not a hidden callback. It's visible in Studio, it participates in checkpointing, and it ensures the snapshot boundary matches the database state. Combined, these 6 axioms ensure the pipeline is a pure function of its inputs, inspectable at every seam. This recursion isn't a gimmick, it's how we architect for trust. When the structure is provably right, technical depth becomes your competitive advantage. I'm Travis Dayton, and this is how we build the future of engineering knowledge.